Alright, so now that we've learned how to kind of put our linear system into a neat, organized matrix, let's figure out how to solve them. So what I'm going to present now is the method to solve a linear system that we use in linear algebra. And essentially what you're trying to do is you're trying to use the variables in one equation, or one specific variable in one equation, to eliminate the other variables in the other equation. So we're going to take the x1 in our first equation, and we're going to eliminate this negative 4x1 in the third equation. And there's not an x1 in the second equation, so we don't need to worry about that. And what we're going to do, this using multiples of each one of these equations. At first this can be a little confusing. I definitely was a little confused by how it's done when I first learned this, but after you do about 3 of these, it all makes sense, and it's very, very easy. So let's go ahead and do this. Just for a little housekeeping idea, in the last video I kind of had our matrix set up like this on the right, where I had the purple as the coefficients and a different color for the augmented side. As we move forward, I'm just going to leave it all in purple. Don't be alarmed, because that part of the matrix is going to change as we kind of do our method to solve the system. So just know that this bar right here that kind of splits down the matrix is what lets you know that you're working with an augmented matrix. All right. So in order to do this, what we're gonna do is we are gonna take 4 times equation 1, and we're going to add it to equation 3. Alright? So, again, we're trying to eliminate the x1s from all of the other equations. And it's helpful to look, and this is why the matrix is so helpful, because all we're really worrying about is the coefficients here. And the reason why we're going to take 4 times the first equation and add it to the third equation is because when I multiply the first equation by 4 and then I add it to the third one, this negative 4 is going to cancel out, and you'll see what we mean by that right now. So we're saying 4 times equation 1. Well, equation 1 is literally 1, negative 2, and I'll go ahead and do this in a different color so it kind of correlates. 1, negative 2, and 1, right? And then we are going to add that, all right, to equation 3. Now equation 3 has negative 4, 5, and 9. All right? And what do we get here? Well, 4 times 1 is 4. And then we're going to add 4 to negative 4. So that becomes a 0. And that's nice. That's exactly what we wanted. Again, we're canceling all this stuff out. Now we're going to say 4 times negative 2. Well, that's negative 8. And then we're going to add it to 5. Negative 8 plus 5 is going to get us a 3. So 4 times negative 2, again, plus 5 is negative 3. All right. And lastly, we're going to say 4 times 1 is 4, plus 9 is 13. So we have a 13. Now, and again, these represent the coefficients. So maybe I'll just go ahead and do these in a different color really quickly. These represent the coefficients, all right, the new coefficients for our third equation in our matrix. So what you do is you actually just rewrite your matrix. And each step of the way, you're going to go ahead and rewrite your matrix down. Again, I'm not going to follow that green coloring. I'm not going to follow that green coloring, but this is the same matrix as above. And again, we're saying, okay, now it's 0, now it's negative 3, now it's 13. And as I previously mentioned, the right side of this matrix is going to change too. So what we actually have to do is also add this in there and say, well, I have a 0 right here as my augmented side, and I have a negative 9 there, right? But realistically, that doesn't change at all, does it? Because 4 times 0 is still 0, and then we're adding a negative 9 to, so we still have negative 9. All right, so now the next step. What you're just trying to do is you're trying to go down each column and get one number in whatever position you can, whatever position you may be. It's a different position based on each column, but you're trying to get zeros under every one of those columns, or under every one of those numbers. So here we have the 1, and now we have 2 zeros. And once you have that, then you move on to the next column. Now, we're done with equation 1, because equation 1 is now the only thing that is represented by an x1 variable. So now that we're done with that, we're going to move on to equation 2. All right? And once we're working with equation 2, we can do a similar process. First, before I even start doing anything to equation 2, I want to scale this down a little bit. You can see that this is all divisible by 2, so let's go ahead and do that. So we're just going to say 1/2 row 2. Okay, here I use equation, and that's completely fine. Here I use row. Those are interchangeable because remember, rows represent equations in our matrix, and variables are represented by the columns. So 1/2 row 1, and now I have everything else is staying the same, so I just get this. 0, 1, negative 4, and 4. And then this stays the same as what we had. There we go. Okay. And now what we want to do, again, since now that we're in the simplest form that we can get, we're going to go ahead and try to eliminate that negative 3 from equation 3. One piece of advice, just in general, when working with this is to always scale things down if you can. That makes things so much easier. So we're going to say 3 times row 2 plus row 3. One thing that you'll sometimes see is people will have minuses here or pluses, whatever they can do to kind of get rid of things. I always add. It just makes things a lot easier. So I always suggest adding 2 rows together. Don't try to subtract a row from another row. So we're saying 3 times row 2. So we're going to take all the coefficients in row 2. We have 0, we have 1, and we have negative 4. Right? And we have the 4 on the back side, right, on this right side of the equation. Don't forget that. All right? And we're trying to add that to row 3. Well, we have a 0 here, we have a negative 3 here, we have a 13 there, and a negative 9 here. So what do we get? We get 3 times 0 is 0. Well, plus 0, now we're just back at 0. Look at that. 3 times 1 is 3, plus negative 3, we're at 0. And this is what we wanted. This was kind of our objective. 3 times negative 4 is negative 12, plus 13 is 1. And then 3 times 4 is 12, plus negative 9 becomes 3. All right, now, and these are our new coefficients that we're now going to put into row 3. All right? 1, negative 2, 1, 0. 0, 1, negative 4, 4, 0, 0. Again, these are this right here, what we just found. 1 and 3. All right? So as you're doing this, notice how we don't ever change any of the rows that we aren't directly dealing with. And we also don't change the row that we're scaling. All that we change is the row that's being added. Right? You can think about this like this. This is a good way to kind of write this down. So you say 3 times row 2, and then you draw a little arrow, and that stands for into row 3. All right? So that little arrow just represents, oh, I'm going to move that into our row 3. And we can see that that's what we just got there. All right? Now, and look at this. We have, and we'll learn more about this soon, but we have this nice little diagonal of 1s. We'll learn about what that means coming up. And notice one other thing that we'll work on in the future videos is that we have this nice little triangle of zeros. And so this matrix is what's in triangular form. This is what we call this, and that's a very special form. It's very helpful. Now, let's think about how we can view this as a system of equations now. And then we'll go ahead and think about how we can solve them in the next video. So we have x1, we have an x2, we have an x3, we have an x2, we have an x3, and in this last one we only have x3, right? Because we have zeros on all of this triangular portion right here, just like in our matrix. So we don't need to even bother writing anything there. Okay, so now we have our coefficients. Well, we have 1 here, we have -2 there, we have 1 here. We have a 1 here, and we have a -4 there. And we have a 1 there. Okay? And of course, these equal everything on the right side. We got to make sure we want to put that in there, because that, after all, is the helping us find our solution, 0, 4, and 3. And now this is what our linear system has gotten to. This is what we've just simplified it to, and it's a lot easier because now instead of having, 3 equations with multiple variables in it, we have one equation that is actually just now one variable. And you'll see what we do moving forward once we get to this form in future videos.